Okay, let us have a very basic discussion on elastic and inelastic scattering. Again, so this is a target nucleus, okay, and this is a projectile. Fine, good. So now, suppose at a time, 1000 projectile nuclei are incident on a single target nucleus. Just assume. Now, as a result of this, what we are able to do, see the numbers. Out of this 1000, we are observing over here 600 nuclei. That means 600 projectile nuclei, they have basically not interacted. There is no change in energy, no change in momentum. See, the direction itself is the same. What about the other? So, we observe that in other directions, we are getting some of these projectiles. So, it is observed that if I sum up suppose I am summing up the numbers, then I find that these other directions number correspond to say 400. So what does this tell me, this picture? So 1000 projectiles impinging on a target. Let us make a different color. Okay. Suppose this is the target. Okay, 1000 projectiles impinging on this target. 600 do not interact, and in other directions I am observing the rest of the 400. Now I did a study on the rest of the 400 and I found that their energy is not changed, the magnitude of the momentum is not changed, and I am getting the number 600, 400. So what this story, this story tells us, what is happening? What is the process?
Momentum are not changed.
Since the energy and momentum are the same, look at the numbers. The numbers are the same. So this is basically an elastic scattering. So this is an elastic scattering process. Okay. Now, in another case, so this is one scenario. Scenario 1. So let me write it down. Case 1. Case 1, here 1000 went in, okay, 600 out there and 400. Okay, next case 2. Case 2. In case 2, what happens is that the number remains the same, 1000. Here, instead of 600, I am observing 800. Okay, I am observing 800. Whereas, if I do this study, I observe approximately 150. So, where is the rest going?
Rest already has been.
You see, 1000 minus 800 is 200. 200 minus 150 is 50. So the rest has been absorbed by this nucleus, and after some time it will be there, because of this absorption there will be some effect. Okay, some emission will be there because this nucleus will go to an excited state. Now this is a typical example of inelastic scattering. Why inelastic scattering? So far as this 800 is concerned, fine. So far as this 150 is concerned, this contributes to, these are the contributions from elastic scattering. So here I will write down again 1000, instead of 600 I have 800, here 150 I have observed, which have same energy magnitude of momentum, only direction is changed. And 50 I have not observed. So this 50 corresponds to the absorbed part of here, which was 0. Now if I ask you what is the percentage of elastic scattering, in which case elastic scattering is more, what will you say? Let's do a simple maths. In the case 1, the ratio of elastic scattering is what?
Is 2/3,
or you can say 1000 by 400. 400 by 1000.
1000.
400 by 1000 is how much?
To be 40%.
40%. What's this in case B? 15%. So in case B, there is 15% elastic scattering, then 5% inelastic scattering, and rest 80% no interaction. And this case, 60% no interaction, 0% inelastic scattering. So this is a basic idea of elastic and inelastic scattering. Now, what we do in experiments, we measure, we put detectors at different angles. These are the detectors. And then we measure these outgoing particles. We measure these outgoing particles and then we get an angular distribution, cross section, angular distribution of cross section. That means how much is emitted cross section and at what angle this gives me. And this is how we estimate angular cross section. Good. Now we are going to talk about optical model, where we are going to incorporate both the absorbed part as well as the unabsorbed part. Now there are two contributions of unabsorbed part. One is that which has been elastically scattered and another which has not interacted at all. Okay, so this just keep in mind. So as a result of this interaction, there are overall three parts. Number one, this part which has not interacted. Number two, this part which has interacted but elastically. So there is only change in angle. And number three, the 50 over here which has been absorbed. That means their energy, their direction, their momentum has changed. So these are the contributions for inelastic scattering. Any question?
Optical model collector.
Now suppose, let me tell you something interesting. Suppose it so happens, let me talk about again case 2, but now little bit different. Case 2. Case 2, again I did the observation and I found the number to be 200. Again, rediscussion of case 2. Suppose this is, and what really happens in experiment, we have to observe. But previously I told you that 50 was being observed. Now there is a possibility that those 50 are not observed. But here you observe this 200. So can you immediately say that here this 200 are from elastic scattering? No. You have to measure the momenta and energy of each of these 200. And after measurement, we observe that only in case of 150, the energy and momenta are the same. But in the case of 50, the energy is lower. Momenta is lower. What will you say? Since the energy is lower, they must have transferred the energy. Where is the place to transfer the energy? Over here. So again, through explicit measurement, this is the importance of putting detectors at different angles that I was telling you. So if it so happens that these 50 are not absorbed, but they are also emitted, but they will be emitted at lower energy, lower momentum. So only by using detectors at different angles. So there is need of detectors at different angles. Otherwise, we will not be able to estimate or find out. You see, these 50 and 150, they look the same, but their angles are overall more or less the same. But again, when I say the angles are same, there is a catch. The catch is this 150, they will be distributed in a way which is different from this 50. Or the angular distribution of elastic scattering will be different from those of the inelastic scattering. Try to understand. I am just telling you the overall picture through very basic examples. Okay.
So the 50 particles are basically detected in the detector's place.
Again, we are detecting it and we are observing it to have lower energy. Right?
Angular distribution will be different.
Yeah, angular distribution will be different means what does this mean? What is the meaning of this statement angular distribution will be different? Tell me, anybody. Let me give you an example. Suppose in this detector and in this detector, what I am observing for elastic case, if I make a ratio, for the inelastic case, the ratio will be different. Very basic idea. Because the physics which is involved during this interaction or the interaction matrix is different. So if this is detector 1 and this is detector 2, the number for elastic, the ratio of them will be different for the inelastic. This is the meaning when I say the angular distribution will be different, or the number of this 50 will be distributed in a different way over this entire angle compared to the distribution of this 150 from elastic, which are contributions from elastic scattering. And you will ask me, why is this different?
Energy.
Because this is decided by the interaction itself. One type of inelastic scattering will have one type of interaction, will have one type of angular distribution. Another type will have another distribution. Think of it like that. There is a store, there is a shop, a child is coming. Suppose the child wants to eat one particular type of chocolate. The child comes to the store and sees there are no chocolate at all. He will just divert, go away. Suppose he finds there is some chocolate, then he will stay. So see, what I am saying is that depending this distribution, where is it going? So it is coming from here, but here it is going more, here it is going less. Who is deciding this? Scattering process itself, whether it is elastic or inelastic. So this is what we say when we mean the angular distribution is different. Now in the next lecture we will derive this Butler's theory of angular distribution for direct reactions. Any question, any query?
Sir, the 50 particles are inelastically scattered, but they are identical. But is their interaction are same kind or different?
Good question. For the time being, assume they are at the same time. Why? There is a possibility that out of this 50, maybe 20 are from one step and 30 are from two steps. There is a possibility. And how am I going to find it? Tell me, how am I going to find it? How am I going to verify what I have just said? The answer is again the detectors. Using detectors at different angles, I am going to observe the energy and then I am going to use my theory to predict at what angle the projectile will scatter out. Right? Whether it is elastic scattering or inelastic scattering or whatever. In this case, there will be no direct reaction. Remember, why no direct reaction? Because in case of direct reaction or two-step process, there will be some nucleon interaction, right? So in this way, I am wrong here. Try to understand what I have just said. I asked you, out of this 50, 20 are from one step, 30 are from two steps. You should tell me, sir, how is this possible? Why? Because here the projectile entity remains the same. Understand? So this is not a case of nucleon interaction. So there will be no such step. This is the case of inelastic scattering, typical inelastic scattering, no nucleon exchange. Okay, so the answer to your question is this 50 will be entirely from inelastic scattering. There will be no contributions from direct reaction or no contributions from pre-compound reaction or so. Try to understand. Don't just nod at everything I say. You have to ask me. Sometimes I will tell you something which is wrong and I will expect you to stop me. Okay? Now, if I observe something different from this reaction, something different, some other species, then that will be entirely from reaction. Either compound nuclear reaction or direct reaction or multiple step reaction, whatever. But if the species is the same, then it has to be from inelastic scattering. Now, you may ask me, sir, this inelastic scattering 50, what is the interaction process? Is this inelastic scattering from nuclear interaction or from Coulomb interaction? That you can ask me. And the answer will be, I have to see, look at the structure of how the Coulomb excitation angular distribution will be, how the nuclear inelastic angular distribution will be. So I have to use theory and calculate and then look into it. Okay?
So all of the 50 particles are inelastically
Inelastic
scattered,
scattered.
but by nuclear and Coulomb excitations.
Nuclear and Coulomb or both nuclear and Coulomb. Okay?
But not in the direct or the pre-compound nuclear reactions.
Any more questions?